Hello, my name is Mark Grimes, and I am a Linux Field Technical Consultant out of the Columbus, Ohio district. And today we are going to go over the iComfort electrical troubleshooting procedures for the S30. I think you'll find this very helpful. And when you have problems such as communication errors, equipment not found, and things like that. So we'll go ahead and get started into our presentation here. Uh, First off, we want to share our core values: integrity, respect, and excellence. And I'm sure we all share these values. I know Linux puts a high value on these. We are going to go over, like I said, the iComfort electrical troubleshooting procedures, and you'll need a good voltmeter for this, a volt ohm meter, and true RMS if possible. RMS stands for root mean square. It is a better meter, but you can probably check it out with just about any volt ohm meter. These are going to be pretty simple checks for you. Okay, so this is the first generation S30. We had a smart hub that had two antennas, and you see here it's kind of laid out with the wiring and so forth with the indoor board, the smart hub, and our mag mount. And we've gone through some upgrades since then. Uh, so this next slide here is showing the second generation smart hub, which only had one antenna, and you can see the terminals and so forth laid out down here on the bottom. These are push tab terminals where you just push the wire up in and it locked into place. But now we are into our third generation S30, and we have screw terminals, which makes it more of a positive connection with your wire. So we have these. You can take a pocket screwdriver and lock these wires in with these terminals much better. Okay. And just be aware that the terminal arrangement might be a little different than the first generation or the second generation smart hub. So just know what terminals you're actually wiring to and not just colors. Okay, so the new 3.0 is a 19V30. That is the catalog number for the new 3.0 stat, 19V30. And this 3.0 has a full sub base that goes on the wall instead of the mag mount. And we do have screw terminals here as well. And like I said, it is a full sub base that we display will snap onto. And as you can see, our terminal designations are embossed into the plastic of the sub base here. So we're looking left to right here. So we have our plus 12 volt DC. Second terminal is your A, and then B, and then your negative 12 volt DC. Okay, your communication here is your A and B. Your power is 12 volts DC for plus and minus. And of course, pay attention to these terminals as well, making sure that you have it wired correctly. Okay, the back of the display has pins instead of the rings. Okay, we have pins that will plug right into the sub base, and you see the four connections where it will snap on to the sub base. We also have a service and application note that has some very good electrical troubleshooting items. You can look this up on Linux Pros. The form number is ACC-17-01. And like I said, it's very good. So you can download that, and that will help you as well to go actually further in-depth troubleshooting than what we're going to today even. So very good document to have. Okay, so let's dive right in here. Okay, so this is a typical wiring layout here of your S30 system with communicating indoor and outdoor units. And you'll see all the wires that they're connected here. It is a 4-wire wiring system. And but we're going to troubleshoot some problems that you may have from voltage induction or voltage leaking. Okay, so we're going to look at both of those, and we're going to troubleshoot both of those. And again, your S30 version 1.0 and 2.0 have spring-loaded tab terminals, but the 3.0 has screw terminals, which I think is much better. It's going to be much better for you. I think you'll like it much better. Okay, in a lot of cases, when you are retrofitting, going in and removing a system and putting in a communicating system, you've already got existing thermostat wire that is there. It's usually multi-conductor thermostat wire. We only need 4 wires, but you may have actually more wires in the bundle than that. We do give recommendations what to do with the extra wires and so forth. And if you follow this, they will help with induction. But we prefer to use two conductor cables. Okay, and we'll talk about that a little bit more here in just a moment. But that's what we prefer. Okay, but if you do use this type of wiring, you'll want to put the extra unused conductors under a wire nut and wire it back to common at the indoor board, just like it is shown here. And this will help drain any stray signals, any inductant voltage. It'll help po possibly drain this back to common, and where it will not hopefully affect our communication bus. Okay, so this wire procedure is highly discouraged due to the amount of cross-talking between conductors. And what that means is voltage leaking over between the wires within the cable. But if you do have cable like this, it is highly recommended that you change it out. Okay, and this here is in the installation instructions showing you what the recommended wire to use. Okay, for your R and C, which is your 24-volt power source, you can use regular 18 conductor or 18 gauge 2 conductor wire. And the I plus I minus, it is recommended to use twisted pair shielded wire. You can use 18 or even down to 22 gauge wire for that. I prefer 18, but that's what you can use. Also for the A and B going up to your display, okay, to your sub base, that is also recommended to use shielded wire, okay, to cut down on inductive voltages. Okay, this next slide here is kind of showing you what we actually recommend. Okay, as you can see up here in this left-hand corner, that is the type of wire that we are asking to use instead of this type of wire with multi-conductor. It cuts down on the possibility of cross-talking or voltage leaking over from in between conductors. So it's a much better wire to use. Also for the communication bus, the I plus I minus or the A and B, shielded twisted pair wire is highly recommended here. So if you can get this would be really good. If not, use 2 pulls of these, two cables of your 2 conductor wire, and that will really be a much better than the multi-conductor wire as you see up here in the right-hand corner. Okay, so as you can see, we'll start over here at the sub base. We are pulling on the communication bus 2 conductors over to the smart hub or down to the smart hub, wherever it is, usually at the indoor equipment. And with regular 18 gauge 2 conductor wire for the power source, I plus or plus and minus here, which is your 12-volt DC. And then from the smart hub down to the indoor unit, the same, okay, our I plus, I minus has a cable here with two conductors, preferably shielded twisted pair, or and also with the RNC, your 24-volt AC power source being two conductor and running down as well. And then from the indoor board to the outdoor board, the same. Okay, that this here will greatly reduce the possibility of inductive voltages, which will cause communication errors, cause the equipment not to operate, cause internet problems, connection to Wi-Fi, app, the homeowner's app, and so forth also can suffer if we get inductive voltages into this. So this is the preferred way to wire this. Okay, in this one, this slide here, the only thing it's added is our zone control if we are using iHarmony zoning. And it's just showing you how to add that in from a wiring standpoint as well. And we do recommend the same thing, two cables with two conductors each, one for your communication bus, one for your 24-volt AC. Also going up to your zone sensors, which is not really shown on here. We also recommend the same thing, two conductor pulls up to the zone sensor from the zoning control. Okay, so let's look at some troubleshooting here. Again, two conductor pulls. That's what we're looking for. Okay, we are showing this with the two black being one cable and the two red being one cable. Okay, and you can see this is a typical wiring layout here. So we're coming from the sub base down to the smart hub, okay, with two conductor pulls. And from the smart hub to the indoor unit, same thing, two conductor pulls. And then from the indoor board out to the outdoor board, the same thing. So using two pair of two conductor cables. So let's look at the first procedure here. This is going to, we're going to be talking about induced voltage. And what we mean by this is voltages that are from outside sources, okay, such as high voltage lines, fluorescent lighting, ballast, and things like that. This is coming from outside the cable and being induced into the cable. If we get inductive voltage into the communication bus, then there's where the boards and the thermostat and so forth have trouble understanding what the signals are, because the inductive voltage can, really, be a bad, it's not good, because it will make the signals uninterpretable. So it will give you communication errors. Okay, so let's look at this. All right, here we have our wiring here and so forth. Same wiring diagram that we've looked at. This is our typical layout. Okay, so the first thing we want to do is disconnect all wires from all of the entities, such as your subbase, from your smart hub, from your indoor board, and from the outdoor board. Okay, all wires are disconnected from all entities. Okay, nothing is connected here. Okay, so what we're going to do to check, we're going to set our voltmeter to AC volts. Okay, and we're looking for a target voltage of 0.03 volts or 0.3 volts. Okay, 3/10 of a volt or less. Okay, that's what we're shooting for here. Okay, and how to check that? We can check that by putting our black lead on common at the indoor board, because there's where our power source is. There's where the transformer is, and the red lead on each wire to see if there's any voltage there. Okay, as we go along here, we check each one, and hopefully we are 3/10 of a volt or less here. Okay, 3/10 of a volt or less. If we are, then that wire would be deemed good from a induced voltage standpoint. Okay, but this is only one check. Later on, we're gonna have another check to see if the wires are actually crossing voltage within themselves. Okay, so once we do that, okay, if we want voltage, like I said, 3/10 of a volt or less, but if it gets over 0.7 volts, this could be a problem. Okay, and if we're much over zero point 0.7, that wire is deemed to be bad and would need to be replaced. And if you replace it, it would be good to replace it with two conductor pulls, okay, two conductor cables. And once you check this one, you want to do the same checks, okay, for your outdoor unit, okay, from the indoor board to the outdoor board, and from the smart hub over to the your sub base, your mag mount. Okay, so sometimes your meter leads are not long enough to reach the points that you need to connect. So we're going to show you how to do that real quick. Okay, we have go ahead and we've hooked up our common wire that goes to the smart hub, and we are going to check our sub base or mag mount wire there. Okay, it's just extending that to the smart hub because your meter leads may not be long enough to reach from the indoor board up to where the wires are for the sub base. And this is one way that you can extend that to make that happen. All right, so we concluded the induced voltage. And like I said, that voltage is, when we say induced, that voltage would be coming from an outside source. Now we're going to look at leaking voltage. So you've already done your check, okay, with all the wires disconnected. All right, and that is for inductive voltage. But now what we are going to do here, we're going to reconnect only the R wire. Okay, we're going to reconnect it and we're going to power up the unit so it has 24 volts on that one wire. Okay, so as you can see here, we have connected it, okay, from the indoor unit only. Again, we're only looking for a voltage that is 3/10 of a volt or less. That is our target. Okay, so how are we going to check for that? We're going to take our black lead, we're going to put it on common of our indoor board, and then we're going to take our red lead and we're going to check all the unconnected wires. Okay, and hopefully we have less than 3/10 of a volt. Okay, so we are going to check each one of those wires. Okay. Now, like I said, any voltage again that we get above 0.7 or 7/10 of a volt is not good. It could cause problems. And if we get over 1.2 volts, it's definitely going to be an issue. Okay, so if we have anything close to that, we'll want to replace this wire. What causes this is insulation on the wire breaks down. The wire is able to conduct the power from the R wire through the other conductors. And if you're getting voltage readings, and it's showing here 6.8 volts, which I've seen a lot higher than that actually, this is a really bad problem. This is, if it isn't a problem today, it will be a problem, and then that wire needs to be replaced. Okay, so here also here's one more check you can do. All right, with the R wire connected, okay, you're getting this voltage. you can actually disconnect the wire and see if the voltage goes away. If the voltage goes away when you disconnect the R wire, it would be crossing from the R wire into the other conductors. If it remains after you disconnect the R here, if this voltage of 6.8 remains or whatever that voltage might be, okay, then it's being induced from an outside source. Okay, so you can, uh, you know, you can actually determine where it's coming from. Okay. And once we've completed this test, we can do the same thing for the mag mount and for the outdoor unit. It's the same test. Just connect the R at the indoor unit and just do the same test. And you can determine if that wire is bad or not. Okay, so if your leads on your meter are not long enough, you can extend the wire, okay, by doing this, okay, and you can check at the end of the wire, okay, to the mag mount. This would be the one that would be the hardest to reach, possibly because of your meter leads not being long enough. Okay, so typical symptoms that we experience with wiring, for inductive voltage problems, okay, whether it's voltage bleed over in between conductors or if it's an inductive voltage from an outside source and so forth. If we have a zoning control, it shows up in the thermostat with you can't find the zone sensors and things like that. It won't show the zone sensors, or you have a missing zone sensor. That all could be caused by inductive voltage. Intermittent issues, intermittently zones dropping out, this and that, or intermittent uh, communication errors. Okay, all of this, even though it works sometimes or it works a lot of the time, but there's times that it doesn't work, and it's showing communication errors in your notifications. The wiring could be the issue. A big one that happens here is the S30 cannot communicate with Smart Hub or the equipment. That would mean, could mean that the wire is bad and we need to do these checks. If it's bad enough, it can cause Wi-Fi connection issues. Okay, so dropping off of Wi-Fi, not having a stable connection to Wi-Fi, that can be a cause. System waiting, okay, that could be a cause. Um, Missing outdoor unit, okay, which be the same as not can't find equipment and things like that. Okay, missing outdoor unit, the wiring could be the issue. Alarms, 105, 120s. I think even a 35 may be a communication error, 31, 35. Okay, all of those could mean that we have wiring issues. Blank screens and the phone app won't connect to the equipment. All of that could be caused by inductive voltages. Okay, here's a very important thing. When you install float switches, okay, or say the safety switches in the uh, drain pan of the coil and so forth, we really need to be using isolation relays. And we do have one other wiring procedure I'm going to show you here in just a moment, but we can't wire these float switches direct. Float switches are very inconsistent and they can cause problems, uh, communication problems, okay, within the communication bus. Okay, so we'll need to use isolation relays. All right, so here's two ways to wire in float switches. All right, option one here, okay, is this one. If all the equipment is communicating, that is the indoor and the outdoor, you can wire like this. This is a very simple way to wire. You are wiring your float switch on the conventional terminals on the board, the indoor board. You are running it between R and DS. Okay, R and DS. This is your float switch. And of course, you'd have to cut your jumper on the board, the R to DS jumper, okay, which is the W914. Okay, if you don't have all communicating equipment, or if you want an alternate way to wire a float switch, here's another option. Okay, these wiring diagrams are in the installation instruction guide for the S30. It does show you in there. That's where I got them. But this is using an isolation relay. Okay, so basically we're wiring the relay coil through the safety switches on the coil. You can put that in series with your float switch as well. Okay, and either one of them opens, it will uh, drop the power to this relay, which will cut the outdoor unit, okay, from running, and that will protect you if we have a condensate issue. So two very good ways. You never want to wire a float switch directly, okay, within the equipment. Always do it one of these two ways. Okay, so some tips here, some installation and service tips to help mitigate these problems. Okay, ground unused thermostat wires. Okay, and that is if you're using multi-conductor wire. Keep your thermostat wire cables away from line voltage sources. Okay, outside the unit. Don't let it get next to line voltage wires or fluorescent lighting ballast. Anything that would create a signal. Replace old damaged spliced wire. Okay, never really want to splice a wire. Okay, if you want to stay away from wire nuts, extending wire. Okay, if your wire's too short, replace that wire with a wire long enough. Okay, if you can. If you do have to splice a wire, make sure you're making a really good connection. Keep it dry. I really don't like that. That's always been a source of a problem. Ensure that your connections on the, like I said, the 1.0 and 2.0 smart hubs all has spring clips. Make sure it's a good solid connection. Even if you have the screw terminals on the 3.0 smart hub, make sure that they're good, secure connections. And then, of course, follow the instructions. Okay. Okay. So one other thing you can do when you're troubleshooting, uh, if your display won't connect to the equipment or it can't find the display, you can take the sub base and display off the wall, bring it down to where the smart hub is, and you can cut a short piece of wire, okay, what we call a short leash. If it operates there, but it doesn't up on the wall, then that's a good indication that the wire, but the existing wire between those 2 points is bad. Okay, one thing that I've done to really help clean up things, especially after there's been problems and you fixed it, okay, is to do a reconfigure on the system. So after you make any correction here or resolve any problems, I highly do recommend that you do reconfigure the system through the reset option in the dealer control center. It's real easy to get to. Okay, you go to menu, settings, advanced settings, view dealer control center, proceed, and then go to equipment. And then in the lower left, you'll see the reset button. Hit the reset. And then the second option down should be reconfigure system. And you'll do that and it will go through a reboot and it'll start over fresh for you. And I have resolved many issues that way. Okay, so that concludes today's presentation. I hope it was helpful to you. Thank you, and I'm sure we'll be meeting again. Thank you and have a good day.